All right, as we start lesson 4 about Cpctc, let's just start with a quick little review of the things that we've learned. The very first thing that we learned was that the definition of congruent triangles means that all three corresponding angles are congruent and all three corresponding sides are congruent, and therefore that makes the triangles are congruent. Okay, and remember that we've also learned how to prove those triangles congruent. We've learned 5 different ways. One is side, 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 angle, side. We've learned angle, side, angle, 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 side, and then we've added in HL. These are ways to prove triangles congruent. The two X's down here at the bottom are the 2 ways that we said we can't use, and those are ASS or SSA we cannot use, and then we can't use AAA. All right, so keep that in mind. All right, so big difference between what we've been doing and what we're going to do today is we are only going to add one extra step, and that extra step is going to be Cpctc. Well, what is Cpctc? All right, Cpctc stands for corresponding parts of congruent triangles are congruent. That's Cpctc. All right, real fancy. What the heck does that mean? Well, let's look at our example here. If I take this picture here, I see that I can prove triangle CAT congruent to DOG. All right, so triangle CAT is congruent to triangle DOG. Everything is given to me. I know that angle C is congruent to angle D. I know that angle A is congruent to angle O. And I know that side CA is congruent to side DO. All right, now I've used only 3 things of the 6 things. Remember, 6 things, 3 sides, 3 sets of angles. Of the 6 things, I've only used 3 in order to prove the triangles are congruent, and I've done that using the idea of angle, side, angle. Now, what this means, though, is that since the triangles are congruent, angle T is now congruent to angle G. So angle T is congruent to angle G, and the reason I can say that is Cpctc. All right, what does that mean? The corresponding parts, T and G, are congruent because the triangles are congruent. I can say that CT is congruent to DG because of Cpctc, that this side is congruent to this side, because since the triangles are congruent, that means that those corresponding sides have to be congruent. And then I can also conclude that TA is congruent to GO, and the reason I can say that is because of Cpctc. All right, so what we've been doing, we have been trying to find 3 congruent statements in order to prove the triangle is congruent. We've been doing that. Now all we're going to do is we are going to take one extra step, and we're going to show a set of sides or angles are also congruent, and our reason is going to be Cpctc. Please make sure you understand what Cpctc stands for. Like, that could be a very simple question on a quiz or a test. All right. Second thing that we're going to do today is we're going to talk about flowcharts. Now, just to kind of narrow in on this idea, we've been basically doing our statements and then drawing like an arrow and giving our reason. Now all we're going to do is put it more in a vertical fashion. So like if I say that BD is congruent to BD and my reason is reflexive property, Well, all we're going to do is write our statement in the box and write our reason underneath it. Very simple. That's going to be our flow chart. Okay? All right, so let's go ahead and look at our first example. In this one, we are given that PQ is parallel to SR. So that is written in this first box. Our reason, just like it's been in the past, is given. Notice that it follows the word given, and so we're going to use that as our reason. Notice that we have another given. The other given is that PQ is congruent to SR. All right, the way the flow chart works. Notice that they're giving us this parallel statement, okay, and then they're drawing an arrow. That means they want us to think about why they would give us those parallel lines. Well, we've talked about that idea of the Z concept. Notice that if I make my Z parallel line, transversal, parallel line, I can conclude that this angle is congruent to this angle by AIA, alternate interior angle theorem. Remember that I have to use 3 letters. I can't say S and Q. So I'm going to go angle RSQ is congruent to angle PQS. Next, I'm going to say that QS is congruent to QS. My reason is reflexive property. And then now that I have 3 congruent statements, 1, 2, 3, and I can mark that in my picture. Notice that I've got my given, I've got my angles, and then I've got my reflexive property telling me that triangle PQS is congruent to triangle RSQ, and I see that it is because of SAS. Alright, so now I'm going to look at what I'm trying to prove. I'm trying to prove that SP over here is congruent to QR. Well, because these 2 triangles are congruent, I can now conclude that SP is congruent to QR by Cpctc. S and P are corresponding parts of the 2 triangles I just proved congruent. Okay, so they are now congruent. So as you can see, the flow chart is pretty much the same thing that we've been doing. We just did it more in a horizontal fashion before. Now we're doing it in a vertical fashion. All right, this one. We get to see a different concept on this one. So in this, we've got kite is a kite. Okay, so KITE is a kite. That is right here. Notice it follows the word given, so that's a given. Now, we got to think about why they would tell us that, okay? While I'm thinking about that, I am going to see that KE is congruent to KI. That is given, and I am going to mark that in my picture. All right, so what do I know about kites? I know instead of opposite sides being congruent, adjacent sides are congruent. Well, they gave me that KI is congruent to KE. I can conclude that IT is congruent to ET. And my reason is definition of kite. You could say property of a kite, something to designate the fact that it's because it's a kite. And just something to kind of think about. A lot of times when we state it as a statement, it's then later on often used as a reason. So notice kite and then kite. All right. Now we need 3 things in order to prove these 2 triangles are congruent. As of right now, we've only got 2 sets of sides. We need to find that third. Well, that third is going to be our reflexive property. We get to see that a lot. So KT is congruent to KT. Our reason is reflexive. And now I see that triangle KET is congruent to triangle because of side, side, side. That means that angle ETK, which is this angle, and ITK, which is this angle, are congruent because of Cpctc. That also means that angle IKT and EKT are also congruent to each other. So angle IKT is congruent to angle EKT because of Cpctc. And since both of those sets of angles are congruent to each other, that means that I can now go to this part, what I'm trying to show, and that is that KT bisects angle EKI and angle ETI. And my reason is because of my definition of an angle bisector. If you think about what an angle bisector does, an angle bisector cuts an angle into two congruent parts, and we showed that here and here by showing that those sets of angles are congruent. Alright, on this page, just so you know, we did not get to this part in class, so don't worry about this. If there's one that you wanted to look at and discuss with me, feel free to bring questions with you to class. Otherwise, we basically started working on the homework.